Hello friends, in this video clip we are going to show the operation of boost converter with the MPP algorithm as Piendo. So this is the facility of the panel. Here total number of panel, that is 12 marking here. We are using the panel number first. The input is tapped from these wire, and at the input side we placed a meter and voltmeter to show or to indicate the voltage and current at the input side, and to measure this voltage and current we use two different sensor. First is the ACS 712 for the current sensor, should be placed up very far from the system, and second this for voltage sensor approx 25 voltage. These signal are given to the Arduino. This is the Arduino cable is connected to this PC, and PC there is a program that is already loaded, and in this screen we are going to see or record the data which is available at the panel side. The output power for the input voltage approx 15.9, that is 43 point something watt, and duty is equals to approx 5.55 around. Input current is around 2.76, and this is the circuit. And according to this, the duty is given to this driver circuit. What is the duty? You can see on the CRO screen, very pretty. This is the duty on the CRO screen, we can see, and you can see on the digital multimeter duty is approx 56%, depending on the temperature and several parameter. Duty is going to hovering at around 55%. And output voltage, that is 28 point, or we can say hovering around the 28 voltage, and this is the voltage required to drive the MOSFET as the low side. And a similar way to provide the cooling, we have the cooling effect by cooling fan at the MOSFET side. And this is the original circuit. We can say this is the PV panel input, and this is connected to input capacitor, and this wire goes to the sensor at the current sensing, and this is the return wire of the sensor, and this is the now the inductor. And after this inductor we have a switch, a MOSFET and channel, and this is the diode, and this is the output capacitor, and the rheostat that as a load is connected through this wire, and this is the load, resistive load, and connected to again this to the ground. Okay, so varying the load. On the variation of the load, we can say what will be the duty. Duty is going to change. In previous, for the RL or load equals to approximately 30 ohm, the duty was around 55%, but now the load is increased. You can see here by sliding the slider. Duty is around 66, or we can say hovering around 65, and the output voltage you can say that the 36.44, and The input current is 2.4 or and voltage around 16, and what is going on the screen you can see here, the power again it is try to feed or transfer the maximum power what is available at the panel side. The input voltage is 16.03 and input current is 2.60 and output power is 14.59 and corresponding duty is 0.64 or we can say 64%. That is required or we need to have. Now you can say for the varied load, for the duty can see on the CRO screen, that is you can say this is the duty approx 65%. For better visualization you can see on the digital multimeter. Okay, next, thank you for watching this video clip.